right, one last problem to look at, and this is a dividing example. Notice that we have the division symbol here. And so we are going to use our keep, change, flip technique just like we did when we were working with numbers on the front page. I do want to make a note that right now all of these are already factored, but you might run into a case where you need to factor something or everything, maybe one or two of the numerators, one or two of the denominators. So go back and look at examples 2 and 3 to see how to factor with a GCF, and then factor using Xbox if you need to for a quadratic. This one, for the sake of just focusing on the dividing part, we're going to start with everything already factored. So I am going to rewrite this using keep, change, flip. So I'm going to keep my entire first fraction, which is x minus 3 times x plus 5. I'm going to divide that by what I already had, x minus 8 and x plus 5. Change to multiplication, and now I want to take the reciprocal or flip my second fraction. X plus 9 times x minus 8. So that comes from the original denominator, and now my original numerator to finish up my reciprocal is x plus 9 and x minus 1. Now, remember that anything that we can no longer see in the denominator of a fraction will need to be written as a restriction. I all of a sudden made my denominator into a numerator, so I can't tell that either of these were originally part of a denominator. So I'm going to go ahead and highlight those. So this right here became this, and I'm going to need to take that into account whenever I talk about restrictions. So I need to account for the original denominator even if I don't cross it out. Sometimes they will get crossed out anyway, but sometimes they won't. So really be careful here. All right, now let's take a look at what we have in common. I see an x plus 5, top and bottom, x plus 9s, and x minus 8s. So I'm going to have x minus 3 over x minus 1 left, and now let's talk about restrictions. Based on my original denominator, x cannot be negative 9 and x cannot be a positive 8. Those also happen to be two things that I crossed out, but again, it may not always happen that way. I'm going to note a restriction that x cannot be negative 9 because negative 9 plus 9 would give me 0. X can also not be a positive 8 because that would make this term 0, and remember that was part of my original denominator. That also happens to be two of the terms that I crossed out, but even if I hadn't crossed them out, they would still need to be accounted for. And then finally, I have x plus 5 that was crossed out, so x cannot be a negative 5, or that term would be 0. So again, two of these were part of our original denominator, this negative 9 and 8.